My name is
Yes.
Miguel Ángel. I am a PhD student of the University of Las Palmas de Gran Canaria, and I will talk about my work analysis of the impact of dataset quality on task-oriented dialogue management. And what is this? What is our task-oriented dialogue management? What is a special class of natural language processing system that are designed to enable users to interact with computer systems or machines. They are a very important research area because their potential to change the human and computer interactions. And nowadays, there are recent progress in machine learning and artificial intelligence has accelerated the development of this system. However, one of the most common approaches is the modular approach that consists in 4 modules. The first one is the natural language understanding modules that take the input of the user, typical a text, and transform the input in one representation of intention, slots, entity, or domains. Then we have the dialogue management or dialogue manager that is composed by 2 systems, 2 modules. The dialogue state tracker that take all the conversation history and transform this conversation into a representation, typical embedding representation, and the dialogue policy. Then this module is responsible to generate the next possible action of the system using the representation of the dialogue state tracker. And the last one, we have the natural language generation that take the action of the dialogue policy and generate output. We focus only in this part, in this dialogue management, because this is the kernel of the system. So there are many approaches to solve this problem. The first one is the more classic. It uses a rule-based system that consists in half countering rules that govern all the conversation problem. But we have the problem of the scalability. Then we have the reformer learning, that is the one most common approach that consists in modeling this problem as if it were a control problem, where the dialogue policy navigates into the action space. However, and this is very common in reformer learning, we need to create a good reward function, and this is not straightforward in many cases. And the last one is a more recent approach using supervised learning and provides a robust alternative to another 2 methods and has been tested with modern deep learning architecture, like for example, transformer, LSTM, etc. And is typical multi-level classification problem. However, we had a little problem, and it's the data limitation. We need a good data and we need a many data. So the main idea of this work is improve the dialogue management through dataset optimization. I mean, the performance of supervised learning model is influenced by the dataset quality rather than the model themselves. So have a high quality dataset is crucial for a fair and balanced evaluation of this model. Although we propose 2 objectives in this project, in this work, the first one is a provided a taxonomy or error in different datasets, in different real datasets, and a synthetic dialogue generator. This synthetic dialogue generator is a tool to generate synthetic datasets with controllable error. So we designed this using a rule-based system because it's for more simple and offer us superior controllability. And this is the generator is not a text generator. Text generator is a symbolic code generator. So this tool generate an embedding with the representation of intention, action, or slots or entities. And we control this with ontologies. That is like a config file that define action, intention, and slot. So in the case of intention actions, we use intention very similar to Multiwoz 2.1. And the intention is a user motivation. We have info intent, that is any specific task. Then we had the inform to communicate slot values, affirm, negate, request, inquiry about slot values, for sign and goodbye, and unknown, that is unrecognizable inputs. And then we had the chit chat, is any intention of topic of the conversation. Then we have the action. That action at the system response. That action can be inform, provide or offer slot information, request, ask for extension slots or ask for extension slots. Then we have the confirm to verify the slot registration, notify to the date of sender status, and record more. That records additional mandatory slot. And then we have the answer chit chat. This any response to non-essential interaction. Then we have different events in dialogue. The first event is a chit chat is any deviation from main dialogue objective managed with chit chat or an answer chit chat action. Then we have the main chaining that occurs when a user modifies the value of already filled slot or decides to let it empty, reflecting a change in the decision. And then we have the domain chaining, when a user shifts focus from one domain or topic to another, indicate change in the dialogue objective. So in the case of error, we analyze the error in Multiwoz 2.1 and CGD. There are two most common datasets of the environment. And the first type of error we have is the natural language understanding error. This is any misclassification of the inputs. Then we have human labeling error, that incorrect tagging intention action error by human annotator. Then we have the temporal reference limitation. This error is an adequate capturing or long-term dialogue context affecting decision making. And we have the ambiguity. That ambiguity is not exactly an error, it's an inherent language ambiguity, but a lending to multiple response for a single state. And that can be confused in many types of models. In the generator, we focus only in natural language standard error and human labeling error, because these two are the most common. So in the case of the dialogue generation, we use a rule-based assistant. We use the concept of stack of topics for managing the dialogue. This is a data structure that manages all the dialogues like a stack, where a topic is composed for a slots that the user must to fill to complete the dialogue objective. Then with this representation of that, we generate a graph. And with the graph, where the nodes are the dialogue states, with intention, la action, and slot, and typically encoding this with 100 embedding, and the lead represent the action. Then we incorporate some randomizing mechanisms for context chaining or introduction. And we use the different perturbation techniques to introduce error. And some rules that govern the system, they are the initialization. All dialogues start with info intent. Then we have the info intent rule. Match its info intents with a slot embedding, with a slots, enabling using to provide or latest slot information. Then we have the confirmation rule. For confirm action follows the info intent to verify slot information. Then we have the mandatory slot request. Request action is triggered for any missing mandatory slot. Then we have the completion notification. This is for notified. And we have the additional information request. Record more action is user once sensation slow are complete, and chit chat handling that is controlled by answer chit chat action. So in the case of our experiment, we use a combination of two datasets, Multiwoz 1 and CGD, and we generate 3 different types of synthetic datasets that increase the difficulty, simple, medium, and hard. This increasing of the difficulty involves adding more slot, topic, and domain in the same dialogues. Then the evaluation metric, we use precision record a phi1 score. This is because it's a multi-level problem. And in the case of models, we use transformer embedded dialogues. This is a transformer that convert all the conversation history into embeddings and then classify that embedding. We use recurrent embedding dialogues. Is the same model like the first ones, only in this case use LSTM. We have the planning chain dialogue policy. In this case, introduce a module to planify the next action, and we have other module that includes LSTM or neural networks. And for all models, we use the original hyperparameter settings. In the case of dialogue state representation, with encode this representation using intention, slots, and action, all together into a one coding embedding. So we train the models using real dataset and the synthetic data, both from scratch. By analyzing the result, we see something very clear. But for both sets of data, there are different almost 10 points between them for all models, which validates the hypothesis of the importance of having good data. Then, and this hypothesis is reinforced by using synthetic datasets and gradually the increase of difficulty of these datasets, where our model maintain a good performance, a very good performance. Then we have the second experiment, and where we start increasing the error in data, and in this case we use the hard synthetic dataset and gradually the increase in the number of error where train and evaluate the models. Here we see that some models like TED and RED, the line, the blue line and the orange line, experiment a rapid decline in the performance compared to others. This is validate the idea of the importation of the data and validate this tool, this generator, like a good tool to evaluate our different models. So the conclusion of this work are the first one: we need to get good data. We need to make good data for build better models and build better evaluation of these models. We propose a error of taxonomy. A classification system has been created to identify and categorize a common error in different datasets. We have the synthetic dataset generator. It's a new tool for developer or say that can be very useful in case you could test your models. And for future direction, could be interesting using hybrid datasets, a combination of synthetic datasets and real datasets. Can be interesting using reinforcement learning. I mean, using the dataset, the synthetic dataset in reinforcement learning algorithms. And of course, this is a very hot topic at the moment, using a large language model in the part of generator or in the part of the dialogue management. So the last one, this project has been supported by the government of the Canary Island and the European Union. So thank you for listening. If you have any question, please let me